Okay, our second section into formal language involves looking at how to describe sets and some of the symbols and vocabulary associated with it. So let's just jump in here and get started with the new words. A set is any group or collection of objects. The objects that belong to the set are the members or elements of the set. Elements or members. One method of denoting a set is simply to list the elements inside braces and label with capital letters. So for example, in set A, I might have the numbers 1, 3, and 5. And so the way I indicate that I have a set is I just use that capital letter, and then I list out the numbers underneath that. Okay, continuing on. Each element of a set is listed only once. There's no need to write repeats. The order of the elements itself are unimportant. It's not wrong if we throw it in any way. You don't have to put it in numerical order. It's kind of like a matter of choice, but there you go. We symbolize that an element belongs to the set using the symbol. It kind of looks like a fancy E. And we use this symbol to indicate that it is not an element of the set. So it actually means the phrase element of. A set must be well defined in order to be a set. In other words, we must be able to clearly tell whether or not an object belongs to a set in order for it to be a valid set. So for example, list out the even numbers. Even numbers, we know. I mean, I clearly know that 2, 4, 6, 8. I can figure those things out. List the set of best taco restaurants. Okay, well, the fact that I threw the word best in there means that not everyone's going to agree. I may or may not, and we might have a couple of overlaps, but not everyone's going to agree that this restaurant title belongs in the set and this restaurant title does not. So well-defined means that the way that they've set up the definitions have to be something that we all can agree upon. Okay, so whenever we are visually describing the elements of a set and what a set physically looks like, there's sort of two main methods that are utilized. The first one is called the listing method. In the listing method, I simply use a capital letter and the brackets, and then I list out all the numbers that fit within that particular set. And if I want to indicate that I've established a pattern, and you should be able to figure that out, I throw in these 3 dots at the end. This stands for what's called an ellipsis. Okay, and the phrase ellipsis means I've established the pattern and thus it continues in this manner. So I don't have to actually write it all out. The other way that we can do set notation is called set builder notation. So I still define it with the set and I still use the curly brackets to indicate that I've got a set. But this is when I want to generate a general criteria for it. So maybe I want to say that it's any number that's either a natural number or but bigger than 20. So what numbers would that be? That would be 1, 2, 3, 4, 5, 6, 7, all the way up to 20, right? So the way I would say that is that it's any number x such that x is an element of the natural numbers and it's also less than or equal to 20. Okay, and so what I've done is I've clearly defined that we're looking at natural numbers and we're clearly looking at anything less than 20. A couple things to point out. That little line there means the phrase such that. This guy we've already seen. That means element of. And then I've listed some sort of conditions or criteria that define that. All right, two sets are considered equal if and only if they contain the same elements. So I can define two sets as equal if all the things, all the members are the same. Order itself does not matter. So as long as it's got all the same numbers or all the same variables or all the same words, then it should be fine. If we have a set that is where that happens, we can write that as, for example, A equals B. We can simply write an equation and say that this set is equal to this set. And if I happen to say that A equals B, then that means we're saying everything in A is also contained in B. And if I say that A does not equal B, that means I can say that there's at least one element that's not in both sets. That there's something in one of them that doesn't exist in the other one. I don't have to specify what that all means. Okay, if the elements of sets P and S can be paired so that each element of P, there's exactly one element of S, and for each element of S, there's exactly one element of P, then the two sets P and S are said to be in a one-to-one correspondence. And there are lines in between the phrase one-to-one that help us identify, or that's part of the spelling. One-to-one correspondence. Okay, the fundamental counting principle states that if event n can occur in m ways, and after it has occurred, event n can occur in n ways, then event m followed by n can occur in m times n ways. Okay, that's not confusing. Let me put some context in this. So let's say you want to go out for dinner and a movie, and you want to know how many options there are. Well, there are, let's say at any given moment, there are 5 movies that you can tolerate, and there are 4 restaurants that you happen to enjoy going to. Okay, so that means how many different date nights or how many different ways can you arrange this? Well, 5 movies times 4 dinner options means there are 20 different ways. So anytime we are using that sort of thinking or that sort of logic, we are applying the fundamental counting principle. Okay, two sets A and B are equivalent. This is kind of like equal. Written A tilde, the little curvy thing's tilde, if there exists a one-to-one correspondence between the sets. Okay, now equal and equivalent sound like the same thing, but they're not. When I say A equals B, I'm saying that they have the exact same things. If I say they are equivalent, that means I can partner up everything in A with everything in B. Back in college algebra, you would refer to this as a function or functional type relationship. Okay, the cardinal number of set S, let me write that out so we can see what I'm trying to say here. The cardinal number of set S denoted by n of S indicates the number of elements in set S. Okay, so let me give you just a short example here. Here's set S, and I'm going to put those elements in it. So if I ask you what is the cardinality of that set, you would simply count up the number of elements, and so that particular example has 4 in them. Okay, an infinite set. Okay, the universal set, let me write that out, and then we'll read out this definition. Oops. All right, universal set is defined as the set consisting of all elements under consideration. So given some sort of criteria, we would define a universal set to be graphically this representation of everything that we are interested in. Typically we use a rectangle to indicate the set, and then I just label in the top corner, I put a U there indicating that this is what I'm saying is the universe of our criteria. And then we go about defining some sort of characteristic, and then we can break it up within each, within the universal set.